Good morning, grade 10s. Today we're looking at a new topic that you haven't seen before. Some of you may remember that I threw it into your grade 9 test towards the end of the year, a Venn diagram. And I did that because I discovered that in grade 7 you briefly see very basic Venn diagrams. So that was a taster of what you're going to learn now in grade 10. Shout out to Mrs. Sutton for letting me use this really cool phone stand that is helping me video some of these videos. So thank you, Mrs. Sutton. Okay, cool. So a Venn diagram basically looks like this. That's how it's spelled. See the phone stand from Miss Sutton? Very cool. Venn diagram looks like this. We have a rectangular shape on the outside that represents everything that falls into my sample space. And on the inside of this rectangular shape, we have circles. And these circles represent events that happen. Remember, events are my favorable outcomes. So it would be favorable outcome of A or favorable outcome of B. So for example, if you think back to what we did yesterday, our event A would have been rolling an even number and event B would have been rolling an odd number. So let's see how this Venn diagram would work with an example. So I'm going to show you how a Venn diagram would look when my event would be rolling an even number. So my favorable outcome is rolling an even number on a dice. So remember, my sample space is made up of all of my possible outcomes, and my possible outcomes when I roll a dice are 1, 2, 3, 4, 5, or 6. And my favorable outcomes, my event A, is made up of these three numbers, 2, 4, and 6, because these are the outcomes that I want to get. So let's see how it would look. Also, side note, shout out to Mrs. Swart for lending me this beautiful polka dot masking tape. Thank you, Mrs. Swart. So all these numbers are in the sample space. 1, 2, 3, 4, 5, 6. And they're floating around the sample space. And what would end up in my event A inside the circle? From 1, 2, 3, 4, 5, and 6, 2 is going to disappear. That's horrible. 2 is going to disappear, and it's going to land up inside my favorable circle. 4 is going to disappear, and that's going to land up inside my circle, and 6 is also going to disappear. So event A is made up of 2, 4, and 6. These numbers are still in my sample space, but these were my favorable outcomes. So grade 10s, I want to introduce you to a new word, and that is the complement of an event. So the complement of an event is the event consisting of all the non-favorable outcomes. So all of the things I didn't want to get. So in other words, everything that is not A. So remember, A we put into our circle, and everything that stayed in the sample space would be our complement. So complement means everything that is not A, that doesn't fall in your circles. So if we had to look at our Venn diagram, these are all the events happening in A. The complement is everything on the outside. So what is on the outside of my event A? 1, 3, and 5. So the complement, also called as not A, the complement of event A consists of 1, 3, and 5 because they fall outside of A. They're not included in A. These are the non-favorable outcomes. So the next terminology I want to introduce you to is the intersection of events. An intersection, as you can imagine, means where something meets. Like if you come to a robot, that's called an intersection because two roads are meeting at the intersection. So the intersection of events. An intersection of events is an event that has outcomes that fall in event A as well as event B. So if I've got two events happening, event A and event B, but they fall in both of them, so and A, B, that part there is the intersection. That is called A and B. And the best example I can give you is some people like chocolate milk and some people like strawberry milk. But some people like chocolate and strawberry. And the people that like chocolate and strawberry would fall in the intersection over there. Some people just like chocolate on its own, some people just like strawberry, but some of them like both of them as well as, and they would fall in the intersection. So the example I'm going to show you with an intersection looks like this. We're still rolling a dice, and event A is rolling an even number. Apparently that's not working. Event A is rolling an even number. So the outcomes in A is 2, 4, and 6. And event B, in my blue circle, is rolling a prime number. Now remember, prime numbers only have 2 factors, one in itself. So our prime numbers, actually 1 is not a prime number because it's only got 1 factor, so I was wrong there. Our prime numbers are 2, 3, and 5. Not forgetting our sample space. Our sample space, because we're rolling a dice, has 6 possible outcomes. So here's our sample space at the bottom. So I'm going to draw in our sample space all over this Venn diagram. 1, 2, 3, 4, 5, and 6. And now I'm going to eliminate. So into event A, I'm just separating them for now. Into event A, we said it's rolling even numbers. So the numbers that are going to fall in event A would be 2, 4, and 6. So we're getting rid of 2, 4, and 6. And we're putting them into event A. Okay? And the numbers that are prime are 1, not 1, sorry, that's not a prime number, but 2, 3, and 5. So 3 and 5 I can put into event B. There's 3.